So part 10, we got to part 10, chapter 9. So in the last video, I explained to you what the queue system is, the continuous review system, and how the formula works for it, right? And I also explained that we need to have safety stock. Why? Why do we need safety stock? If you answer to cover for variation, you got it right. To cover for variation in demand, because demand is not going to be a flat line. Is going to be, a little bit more, a little bit less. You never know what you're going to need next day. So because of that, we need to set a few things. One of them is called service level. So service level is our desired probability of running out of, not running out of stock of an item. Okay, so it's the probability of having the item on inventory. Okay, basically when talking about variation, when it's saying that it could be a little more, a little bit less, there is a probability associating things going a little bit more, a little less, and that's the service level. So we're going to say, oh, we need to have a 95% service level. It means that 95% of the time we're going to have enough material to cover for that period that we order and between we order and we received. And that's what we call a protection interval, the time between we order something until we actually receive something. Okay. And here I know something that you guys love to see, because it brings a lot of good memories for all your stats class. And weirdly enough, TV is talking a lot about stats, right? And curves and graphs and models and all that. So what is this? Bell-shaped curve, right? The normal distribution curve, right? So imagine that we collected data. We're going to do a histogram now, right? This is a histogram. We collected data about anything. Let's say student's height, right? So we took all of you guys, 60 of you, collected all your different heights. And then, there's always an average, which will be the middle point. Take everything, sum, divided by the number of individuals. There's always going to be, people that most of the people will probably be around the mean, okay? Be a little bit high, a little bit lower than the mean. It will be a few of you guys that they're going to be shorter, so lower than the average, right? And there's going to be a few of you guys that would be very tall, so you're going to be more, farther away from the average, right? And that's what we call normal distribution. And most of the data that you collect in a population will have kind of a normal or normish, normalish, something like that, distribution, right? So if one question is, okay, what if we use just the average to calculate our reorder point, right? Take the average, say on average I use a roll of paper. It takes 4 days. 4 times 1 is 4 rolls of toilet paper that I need, okay? So if the demand was, and imagine that this is not the height anymore, this is the demand. So this is, 1 roll of toilet paper will be exactly here, right? So 1.1 rolls, 1.2 rolls, 1.3 rolls, let's say it's 0.9 rolls, 0.8 rolls, 0.5 rolls, 0.6 rolls, and so forth. So let's imagine that this is the chart that we're looking at. So basically saying, okay, if I have 4, I'm going to be covered for every time that demand is on this side, right? So every time that I consume less than the average, I'll be okay because I have 4 rows. The average is 1 per day. 50% of the time, I'll be covered, which is everything that happened below the average. What do you guys think? It's good to have toilet paper 50% of the time? No, right? We need to have toilet paper 99, 95% of the time, right? We want to have most of the time, right? So every time that I increase in 1 standard deviation, 2 standard deviation, 3 standard deviations, every time that I'm increasing more inventory in that reorder point, what happened is that my probability of having the product is going to increase. So let's say I'm going to use 1 standard deviation. So I'm going to have this amount of inventory. If my demand is here, 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 or here during that 4 days of lead time, I have enough toilet paper, right? But if my demand is here, here, or here, I'm going to run out of toilet paper. Then I have to use napkins or newspaper or whatever people are using instead of toilet paper, right? So that means that I'm going to cover for more than 50% of the time. So I'm increasing my service level. I'm increasing my probability of not having a stock out when I'm adding 1, 2, 3 standard deviations into my reorder point. So how much is that? Well, I told you guys that if I only use the average, I'm covered for 50% of the time. My service level will be 50%. If I add 1 standard deviation, I'll be covered for 84.1% of the time. So that's everything that is here and here in my curve. If I use 2 standard deviations, I'll be covered for this. So all this. So I'm only going to have a stock out in this amount of time. And if I use 3 standard deviations, well, I'm covered for 99.9% of the time, which will probably be the wiser thing to do to item like toilet paper, right? Means that here, the space here is only 0.1%, right, of the probability of the occurrences. Okay? So that's why we need safety stock, to cover for all the times that your demand is higher than your average. Okay? So does that make sense? So basically that's what this one is also explaining. Let's say that I set my service level for 85%. So I set my reorder point for 85% here. It means that I'm going to acknowledge that there's a 15% chance of having a stock out, but that's okay. And then I'm recover for the demand to be around here, here, here. I'll be good, right? And I need to add to the average demand during lead time. I need to add z times the standard deviation. Okay, so if you guys remember, this is the symbol of the standard deviation. We talked about that a little bit before when we talk about quality. And the z-score is actually how many standard deviations I need.